Hello, in this lesson we will be solving a quadratic equation involving maximum area. And the problem says a farmer has 360 feet of fencing to build a rectangular pen along a barn wall. The barn acts as one side, so fencing is needed for only three sides. What is the maximum area that can be enclosed? Let's highlight some key terms here. We know that a farmer has 360 feet of fencing, and we only need three sides of fencing since the barn acts as one side. And then it goes on to ask, what is the maximum area that can be enclosed? Let's visualize this by drawing a rectangle. And we know that the barn acts as one side, so there is no fencing there. And then we have two sides, which is the width, and then we have the length, the front facing side. And so the total amount of fencing equals 360 feet, and it's used for the two widths and the one length. So what we're going to do is write 2W, which stands for the two widths plus the length, equals a total of 360 feet of fencing. Okay, and so now we'll solve for L so we can write everything in terms of W. Let's go ahead and do that. We'll subtract 2W from both sides. Okay, and so that equals L equals 360 minus 2W. Area equals length times width. So let me go ahead and write that down here. Area equals length times the width. What we're going to do here is substitute for L. So we'll go ahead and do that because remember we found L right here. That's 360 minus 2W. So we'll just fill that in. So we have area equals the length, which is 360 minus 2W times the width, which is W. Okay, and so what we're going to do is simplify by distributing and multiplying. And we have 360 being distributed to W, which is 360W. And then we have negative 2W being distributed to W, which is negative 2W squared. And so what I'm going to do is just turn this around so where it says A equals negative 2W squared plus 360W. Okay, so this is a quadratic equation that models how the area changes as the width changes. So now we want to find the value of W that makes the area as large as possible. And because the coefficient on W squared is negative, as you can see it's negative 2, well, that means the parabola opens downward. So the parabola looks like this, and it's opening downward like that. Okay, so this means the vertex gives us the maximum area, and the vertex formula tells us where that happens. So our vertex formula, and so remember that will be W, because we're talking about width at this point, equals negative B over 2A. Now let's identify our coefficients on the quadratic. We see that A is negative 2 and B is 360. So let's plug in those values. So we have negative, and B we're told is 360. and that is over 2 times a, which is -2. We see that -360 divided by -4 equals 90. So our width is 90. Okay, so now what we're going to do is substitute some more values here. So you see how we found L equals 360 minus 2W. Now that we know W is 90, we can use L equals 360 minus 2W. So let's go ahead and do that. So we have L, let's see, L equals 360 minus 2 times W, which is 90. And that equals 180. So as you can see, we found the length and the width. And going back to our formula, we have area equals length times the width. Oops, let me make that a little bit more neater. So we have area equals the length times the width. And we know that the length is 180. And then the width is 90. So that equals 16,200 square feet. And that is our final answer. Okay, so that is how you can solve a quadratic to find the maximum area in a real-world fencing problem. So keep practicing and stay tuned for more calm, clear algebra lessons right here on Math by TV.